Hello everyone, my name is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. Today we are going to discuss about single sideband suppressed carrier. Then in this topic we have to discuss introduction to SSB-SC, power calculations of SSB-SC, advantages and disadvantages of SSB-SC. So go to step by step. First of all, what is SSB-SC? The full form of SSB-SC is Single Sideband Suppressed Carrier. In the previous lecture, we learned about a DSB-SC signal processing. What is a DSB-SC means? Double Sideband Suppressed Carrier. Actually, in the case of AM, when you are taking amplitude modulation, we had carrier plus upper sideband and then lower sideband. This is called as a conventional AM or double sideband full carrier system. After that, we go for the next AM technique is DSB-SC. In this case, double sideband suppressed carrier. It consists only upper sideband and lower sideband. And you go for the next under AM technique is SSB-SC, single sideband suppressed carrier. Here, either USB or LSB. USB or LSB. So, what is the main difference? Once you reduce the carrier, what is the advantage? Once you reduce the sideband and carrier, what is the advantage? How the information can be transmitted with the one single band? These all the things can be explained very clearly. If you suppress the carrier, you know very well, the carrier does not consist of any information, but it is useful to transmit a message signal to a long distance. When you suppress that carrier, the power wastage should be reduced and there is no information is lost. What is that process? That is called as a double sideband suppressed carrier system. And go for the third one, SSB-SC, single sideband suppressed carrier. That means here clearly what the upper sideband consists the information. The mirror information is consisting FC minus FM, nothing but a lower sideband. Nothing but what the information we have in the case of upper sideband, the same information, nothing but mirror of the upper sideband, nothing but a lower sideband, the same information it can consider. Therefore, you can suppress any one sideband, either lower sideband or upper sideband. Automatically, the lower sideband power wastage should be reduced. This is the advantage. The information is not lost. Therefore, you need to learn how to reduce the double sideband to single sideband. That concept is known as single sideband suppressed carrier. Here, observe here, the double sideband modulated signal has two sidebands since the two sidebands carry the same information. Clearly, if you transmit the same information within the two bands, automatically you can reduce one sideband. You think the information is not lost. That's why we can go to the SSB-SC. We can eliminate one sideband. This is called as a single sideband suppressed carrier. The process of suppressing one of the sidebands along with the carrier and transmitting a single sideband is called as single sideband suppressed carrier. Single sideband suppressed carrier. Then the carrier, nothing but if you take the frequency of that one, FC, and the lower sideband, if you take the lower sideband, you need to suppress means FC minus FM. Hence, the upper sideband is used for transmission. Therefore, FC plus FM only you need to transmit the information. You think FC does not consist any information. FC minus FM consists the information. FC plus FM, it is also consists the information, but what the information consists FC minus FM, the same information is consisting in the case of FC plus FM. Therefore, you don't need transmit twice the same information at a time. Then you need to stop one FC minus FM means lower sideband you need to stop. Then here the next point, similarly we can suppress the carrier and upper sideband while transmitting the lower sidebands. Okay, If you transmitting only FC minus FM, automatically what you can suppress? FC carriers and FC plus FM upper sideband. And this SSB-SC system, which transmit a single sideband, has high power, as the power allotted for both the carrier and other sidebands is utilized, transmitting the signal, otherwise single sideband. Single sideband. Therefore, here the bandwidth point of view, observe here everyone, if you take the AM, nothing but a conventional AM, DSB-FC, the bandwidth is 2 FM. And if you go for DSB-SC, the bandwidth is, it is also equal to 2 FM because the two sidebands, FC plus FM, minus FC, minus into minus plus, therefore this is 2 FM. And go for the SSB-SC, only one sideband. Only one sideband means FC plus FM or FC minus FM, the carrier. Therefore, here the bandwidth should be equal to half of the DSB-SC, nothing but FM. Half of the DSB-SC, nothing but FM. That's why here the bandwidth of the SSB-SC modulated wave, its bandwidth is half of the bandwidth of the DSB modulated wave, then it is known as SSB-SC bandwidth. That should be equal to FM. That should be equal to FM. Just compare. 2 FM is nothing but AM bandwidth and 2 FM is nothing but DSB-SC bandwidth and SSB-SC bandwidth is FM only. Then the mathematical expression, because you need to get the only one sideband information at the output of the SSB-SC. Observe here, the modulation process in which only one sideband is transmitted and with the carrier suppression is called as a single sideband suppressed carrier. Then clearly observe here, I am taking a modulating signal. Mathematically it is represented M of t is equal to AM cos 2 pi FMT, where AM is nothing but amplitude of the message signal and FM is nothing but frequency of the message signal. And I am taking another signal, carrier signal, that should be C of t is equal to AC cos 2 pi FCT, where AC is nothing but a amplitude of the carrier and FC is nothing but a frequency of the carrier signal. Then mathematically we can represent the equation of SSB-SC. Observe here, the carrier is suppressed. When you are observing AM equation, what is that? AC cos 2 pi FCT, AC AM by 2 cos 2 pi FC plus FM into T, AC AM by 2 cos 2 pi FC minus FM into T. This is the AM equation. If you see the DSB-SC equation, AC AM by 2 cos 2 pi FC plus FM into T plus AC AM by 2 cos 2 pi FC minus FM into T. Just compare AM equation, DSB-SC equation with SSB, either upper sideband or lower sideband information. Observe here, AC cos 2 pi FCT, in the DSB-SC there is no AC cos 2 pi FCT. In SSB-SC there is no AC cos 2 pi FCT. And observe here, in the case of AM, upper sideband information, lower sideband information is there. In the case of DSB-SC, upper sideband information and lower sideband information is there. And comparing with the SSB-SC, observe here, if you consider only upper sideband, what is that? S of t is equal to AM AC by 2 cos 2 pi FC plus FM into T. This is the upper sideband information. Or if you want to get only the lower sideband, AC AM by 2 cos 2 pi FC minus FM into T. Then compare DSB and SSB, only one sideband we are getting at the output of the SSB-SC. That's why it is known as single sideband suppressed carrier. Then, with passing of information through single sideband, how much power you are calculated? What is the power? Observe here, Consider the following equation of the SSB-SC modulation. I am taking the first upper sideband or lower sideband. You know what is that? PT is equal to PUSB is equal to PLSB. You can, because when you take the AM point of view, the total power is nothing but PC plus PUSB plus PLSB. And in the case of DSB-SC, the total power is equal to PUSB plus PLSB. PUSB plus PLSB. Then, in the case of SSB-SC, the total power is equal to PUSB or PLSB. Either, only one sideband power is required. Then, with respect to this formula, you are finding the power of the sideband. Observe that only I am considering one single sideband, AM AC by 2 by root 2 whole square by R. This value should be AM square AC square by 8R. Once comparing this power value with the DSB-SC, the DSB-SC power is AM square AC square by 4R. But in the case of single sideband suppressed carrier, the sideband power, either upper sideband AM square AC square by 8R, either lower sideband, it is also AM square AC square by 8R. That means the total power in the case of SSB-SC should be equal to AM square AC square by 8R. Then, what are the advantages and disadvantages of single sideband suppressed carrier? Remember, first point, the bandwidth or spectrum space occupied is lesser than AM and DSB-SC. Already I told, in the case of AM, 2FM. In the case of DSB-SC, it is also 2FM. But in the case of SSB-SC, it should be equal to FM. That means the bandwidth or spectrum space occupied is lesser than AM and DSB-SC waves. Next one, transmission of more number of signals is allowed. Multiple number of signals should be allowed by using a single sideband suppressed carrier. The power is saved. We know the power is saved. How it is saved means there is no carrier, there is no one sideband. The total power should be reduced. Only one part should be passed needed of the power. And next one, high power signal can be transmitted. What is the meaning of high power? Means high amount of signals can be transmitted and less amount of noise is present comparing with the AM and DSB-SC. And the signal fading is less likely to occur. When you are passing this information into the through the cable or whatever, the fading effect, nothing but multiple attenuations at low frequencies, that should be less when you are taking the single sideband suppressed carrier system. That is the advantages of single sideband suppressed carrier compared with the other techniques. Then what are the disadvantages? The generation and detection of SSB-SC wave is complex process because we need a circuit complexity. You are taking the number of blocks. And the complexity is more compared with the AM and DSB-SC. Next one, the quality of the signal gets affected unless the SSB-SC transmitter and receiver have an excellent frequency stability, because without stability it is a loss. That means automatically what is that? The quality of the signal gets affected unless the SSB transmitter and receiver have an excellent frequency stability. That is the one drawback in the case of SSB-SC system. Then what are the applications? We know the advantages and disadvantages where this single sideband suppressed carrier system is applicable. That means first of all, for power saving requirements and low bandwidth requirements point of view, both are. The power saving means only PUSB or PLSB, or the bandwidth should be only FM. Next one, in land, air and maritime mobile communication systems, we are using this SSB-SC modulation. And point-to-point communication, radio applications, in the radio communications, in the television, telemetry and radar communications. And in military communication such as amateur radio systems, because overall observe these applications, maximum it is useful in the case of point to point communication, transmitting the information between one point to another point. That information is actual information, that passing information with low power, low noise. Then these applications are especially observed in the case of TV transmission, radio communications, and any military communications such as radio system, amateur radio systems. Therefore, SSB-SC is a powerful technique transmitting the information with low power. Then, what the things we discuss in the lecture means, we discussed what is the introduction of SSB-SC and comparison with the DSB-SC and bandwidth considerations of SSB-SC and advantages and disadvantages of SSB-SC and applications of SSB-SC. These are the things we covered in this lecture. In the coming session, we are discussing for SSB-SC generation methods. Nothing but what methods we are using to generate an SSB-SC waveform. We know very well SSB-SC waveform means the output of the SSB-SC modulator should be only one sideband information. Therefore, what the methods we had to generate only a single sideband at the output side? Nothing but SSB-SC generation methods. Thank you.